NVIDIA and VMware are two names that enterprise and communication services providers, CSPs, have trusted to deliver solutions that address the challenges of securely running modern, accelerated workloads alongside existing enterprise applications on any cloud. As an example of this close collaboration, we are introducing a design that combines VMware Cloud Director and VMware vSphere with NVIDIA AI Enterprise software and GPUs to bring AI to every enterprise on a multi-tenant provider's edge. AI can transform every industry, from credit card fraud detection through public safety to product recommendations for e-commerce visitors per day. The demand for fast, easy inference deployment is greater than ever. Moreover, in each of these industries, every common business function, whether it is HR, marketing and sales, or product development and the operations that define it, can be infused with and improved by AI. But how can enterprises use these new edge AI applications without incurring the cost of deploying dedicated infrastructure to support them? VMware NVIDIA's design enables CSP's customers to benefit from a whole dedicated infrastructure experience with the cost-effectiveness of an as-a-service access model on a shared telco edge. Running on NVIDIA-certified systems, which include NVIDIA GPUs, NVIDIA Connected SmartNICs, and NVIDIA DPUs, this reference architecture is composed of the NVIDIA AI Enterprise Suite, which includes AI and data analytics tools and frameworks, cloud-native capabilities for Kubernetes container management, GPU virtualization software, and networking and I/O software for optimized performance, and VMware vSphere and VMware Cloud Director to streamline the deployment and management of any size GPU in a multi-tenant model for AI, machine learning, and data analytics workloads. VMware vSphere integrates with NVIDIA GPU virtualization software to provision, manage, and share GPUs in virtualized environments. VMware Cloud Director manages the access to these shared GPU resources among tenants. The NVIDIA AI Enterprise software suite is optimized and certified to run on VMware vSphere and VMware Cloud Director, resulting in near bare-metal performance for AI workloads in a virtualized environment. This is how this design works. The testbed for this demo is composed of two data centers, one regional hosting the management cluster, which includes VMware Cloud Director, and one edge data center containing a single NVIDIA-certified edge server hosting one NVIDIA T4 GPU, vSphere supporting NVIDIA GPU virtualization software, and finally, the NVIDIA AI Enterprise Suite. This demo will show two separate tenants sharing the same GPU resource on a single host. One of the workloads is running Windows in one of the tenant environments, and the other is running computer vision application suite called Chooch. The first step of this demo is to verify that all components in the Edge data center are up and running. The Edge's VMware vCenter GUI shows a single node deployed on the Edge data center. This node hosts a single NVIDIA T4 GPU that is recognized by VMware vSphere as a graphic resource and that has been configured with shared direct setting for vendor-shared pass-through graphics. There is also a telco edge resource pool defined to help VMware Cloud Director create tenant-based resource pools as they are deployed. In this case, retail and telco. The next step of the activation is to verify that VMware Cloud Director is active and controlling the resources of the Edge data center. Logging into VMware Cloud Director, the GUI shows multiple organizations, and among them, the retail and telco tenants are used in this demo. Each of these two organizations has a virtual data center, or VDC, underpinned to the same provider VDC. Notice there is an NVIDIA icon next to each of the organization's VDC, indicating that a virtual GPU utilization policy has been associated to these VDCs. Virtual GPU policies are used to define desired GPU characteristics, ranging from the GPU profiles like compute or graphics, to the size of the memory and CPU's utilizations. With the environment up and running, a first tenant can now log on to the organization's VDC and launch an application. In this case, the Telco Cloud Group accesses the portal to launch a Windows 10 VM supporting a GPU driver. The tenant clicks on New VM and configures the name for the VM, the template selection with storage policy set to default 1, and the compute type, in this case, vGPU enabled. Then, the vGPU policy is selected, loading with it the requirements for memory and CPU. The VM deployment process concludes with the configuration of the VM's networking. After a few minutes, the Windows VM is running. The compute resources for this VM show the VM attached to a virtual GPU profile. And logging into this Windows application to explore the device manager, it shows an NVIDIA T4 GPU installed. Using the same process, the other tenant, Retail Food, deploys a computer vision application suite called Chooch. The compute resources for this VM show the VM attached to a virtual GPU profile. And logging to Chooch AI Applications Portal and accessing the Devices tab shows NVIDIA's GPU as an active device. Now each tenant's VMware Cloud Director Organization VDC shows a different application active and making use of GPU resources. And even though the applications are operating in complete isolation from one another, they are accessing and sharing the same physical GPU. To summarize, this demo has shown how NVIDIA and VMware have designed a technical proposal for CSPs to bring AI to their enterprise customers as a multi-tenant service running on the telco's edge. But this is one of many examples of the collaboration between VMware and NVIDIA to enable and support communication services providers' journey to modernization and monetization of the edge.